this whole thing without changing any logic, just by saying exit when n equals 1. Cleaner. Yes?
Yep.
Very good. We call that version 2. You can see that I'm not making big steps. I'm making tiny little baby steps when I write my algorithm. Next thing we want to do is to say, yeah, but I know n does not start with 1. Okay, so version 3 will give us certain restrictions, and we'll just say that given that n is greater than 1 to begin with, okay, how are we going to, what do we want to specify in the loop so that n will eventually becomes 1? What do we want to put in the loop here? Okay, we can go back to our example here. What do we do per step? Yep, go ahead.
Divide the number by 2 until it can no longer be divided by 2.
But we don't know whether 2 is a prime factor of n. Can we just ask Joe again? Remember Joe? We like Joe. So we will just say, ask Joe what is a prime factor of n. Why not? If Joe is around, make use of him. So we say, or her, Joe can be a she too. Little women. So we say, find a prime factor f of n, which is equivalent of asking Joe, tell me a prime factor of n. Is that okay? Does this statement tell me how it is done? No, but it does tell me what needs to be done, and it has to be done in a loop and before the following operations, right? So it still serves a very important purpose, even though it is just quote-unquote a placeholder. The next thing I want to do once I find a prime factor f of n, I might want to print it out. I want to show the end user this is a prime factor f. So print f to the screen or on a piece of paper, whatever, doesn't matter. But if you look at our example here, what are we doing to n for each iteration? We start off with 72 as the number to factor. In the next iteration, it becomes 36. How do we go from 72 to 36? We divide a number by the prime factor that we just found, right? So we go ahead and express that logic here. We say, n is going to be n divided by f. We're basically, reducing n and say, in the next iteration, this is the number that we want to factor. Is that making any sense? And that's it. This is the main logic in the loop. Great. Excellent. Now, we go back and say, yeah, but loop and loop does not match any of the loops that we have talked about in the class. We talked about pre-checking loops using the while do. We talked about the post-checking loops using the repeat until. Loop and loop does not specify when the condition is checked. It simply says, at some point we have to get out. When we get out, this condition has to be true. But it doesn't say that we should check for that condition first or whether we should check it after an operation. What do you guys think? What should I do here? Should I do a pre-checking loop or a post-checking loop?
We should do a pre-check because if 1 can't be a prime number, why even bother checking it out?
Exactly. So we can do it like this. You can say, oh, this is version 4. So version 4 is basically saying, we don't want to use a vague loop. We want to use one of the pre-checking or post-checking loop to indicate when we check the condition. So in this case, we'll say while blah, 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 do, and while. We know what needs to be done in the middle is going to be the same as here. So we'll copy and paste that stuff. What do I put here? The exit condition is when n equals 1. So the stay in loop condition, the as long as condition, is going to be what? When n is greater than 1. Very good. So when n is greater than 1, then we perform the following operation. Okay? So this is how I would write an algorithm. You can see that when I write an algorithm, I do not start with, oh, I know this is going to be a while loop. These are the things I'm going to do, and while. I do not type the program sequentially. Okay? I start off with just a very simple idea and say, I know I have to do something again and again. It has to be a loop. But once I specify it as a loop, I have to ask myself, when do I get out of the loop? Is there a condition I can use to tell me when I'm supposed to get out of the loop? Yep, go ahead.
Find a prime number factor of f. Is that a subroutine in itself?
It can be a subroutine. It can just be another chunk of code that we will paste in a little bit later. But for the time being, the most important part is this is a quote-unquote pseudo operation. It is not an assignment statement. It is not a conditional statement. It is not a loop. It does not match any type of statement that we have seen so far. It is simply saying what needs to be done. It does not say how to get it done. But that's fine because we are trying to explain what is top-down design. We're trying to hide the details so that when we're trying to figure out the outer portion of this algorithm, I don't want to have to deal with all the details of finding a prime factor f of n. I can defer that later. If you look at this as Google Maps, this is the map of the United States. This is the state of Nevada. I don't need to know the details of Nevada just yet. I just need to know it is next to California. It is also, in the western states. That's all I need to know at this point for what I'm doing. Now later on, if I'm planning a route and I know that I have to go through Nevada, then I zoom in and I ask myself, how do I get from this end of Nevada to the other end of Nevada? What would be the best path, or what would be a scenic route and whatnot, whatever the criteria turns out to be. But at this point, I don't care, because at this point, I just want to know where is Nevada in relationship with the other stuff that is at a higher level. Is that making any sense so far? I hope so. So next time when we come back on Tuesday, we will go in and try to explain how do we find a prime factor f of n. There's the obvious way, which is slower, and then there's a faster way. But the faster way, guess what? Involves mathematics again. So we'll deal with that next time.
I would say that involves adding Joe.